Okay, we're going to look at exponential decay. Okay, and we have to compare some formulas. This is our exponential function, a being our initial value wherever we start, b being our growth rate, whatever we're growing or decaying by, and then x kind of usually represents a function of time. Here's usually a model for decay. A value, same as our original. The b, this growth is a little different. Okay, growth for decay is usually built off 1. 1 represents the idea of 100% of something. Whoops, I didn't know that happened. Okay, and d, we subtract by d. D is our decay rate. That's usually some type of percentage. Okay, and growth is just the opposite idea. Same thing. Our b is kind of broken up, and it's 1 plus whatever we're growing by, which is some percentage. Okay, so this question is asked us. They've given us this. What was it? Y is equal to 220 and 0.68 t, and they want to know, is this growth or decay? How can you tell? Why is it what? And then we can find out a whole bunch of other information about that. Okay. Well, let's first try to relate it to one of these two models. Actually, let's first relate it to our original. Which is our a value? Which of the numbers in our question is the a value? What number?
220.
220. Great. So that's where we're starting. Apparently, they start with 220. What's our b value?
The 0.68.
0.68, and the x is the
T.
D. Great. That's t. T usually represents time. Okay. So, with that being said, this number here, that looking at our growth and decay, it's one of these two. Okay. They've done something with our b. Okay. They've clearly carried it out. So I want you to think, if 1 plus, and always think if a percentage is going to be like a positive value. If we're adding something to 1, will we get a number less than 1? Will we ever get anything that is less than 1? No. So that means this is not a growth because this is a value that is less than 1. And in which case, if we have 1 and we're subtracting a value, most of our values are going to be less than 1. So decay is what we're looking at because this is less than 1. That's really important. 1 would represent 100%. In other words, you're like staying the same. You're never really changing. Anything greater than 1 means we're growing, and anything less than 1 means we're decaying. Okay, so we kind of have to make a reference to 1. We need to figure out, we're going to break this into the value of 1. So I'm going to turn this into a small formula. Okay, we're going to say that the b value, okay, is equal to 1 minus our decay rate. Okay, that's what our little b is, right? We said b is equal to 1 minus d. Do we know what the b value is in this question?
0.68.
Yeah, 0.68 is equal to 1 subtract d. Well, I have one variable now, so I can solve for it. I'm just going to isolate for my d to find out what the decay rate was. So in order to do that, I move 1 to the other side, so we get let's use black here. 0.68 minus 1 equals negative d, so we'll have to do something at the end there. Okay, and we use our little calculator. Okay, it'll work for this. 0.68 subtract 1 gives us negative 0.32. So we get negative 0.32 is equal to negative d, which means what's positive d equal to?
0.32.
0.32. Now, how do I turn 0.32 into a percentage?
Multiplying by 100.
Yeah. So if I multiply this by 100, what does it do to the decimal places?
Moves it 2 places to the right.
Yeah, we multiply by 100. It does that. What's our percentage?
32.
32%. So what that's saying is, remember our little b here, okay? Recreate it. The b there is 1 subtract 0.32. So not only do we tell them it's decay, but we told them what the percentage is. It's decaying by 32% every whatever t is. Maybe it's year, maybe it's day, maybe it's minute, second. But 32% it's decaying by every amount of time that is. And that's all they really want to know.